Hello, my name is Valentino Ruso. I am a student of Class B, Information Systems. My student ID number is 241,011,060,045. Today, I will explain the topic of transistors. A transistor is a semiconductor device used to amplify or switch electronic signals and electrical power. It operates by controlling the flow of electric current through a semiconductor material, typically silicon. A transistor has three main regions. 1. Emitter E, emits charge carriers, electrons or holes. 2. Base B, controls the flow of carriers between the emitter and collector. 3. Collector C, collects the carriers emitted by the emitter. There are two main types of transistors. Bipolar junction transistor, BJT, uses both electrons and holes as charge carriers. It has two configurations, NPN and PNP. Field effect transistor FET relies on the electric field to control current flow. Common types include MOSFETs and JFET. Working of a BJT NPN transistor example. 1. Base emitter junction. Forward biased by applying a small voltage. This allows electrons to move from the emitter to the base. 2. Base collector junction. Reverse biased, creating a high resistance path. However, a small number of electrons in the base are pulled into the collector due to the applied voltage. 3. Amplification. A small current in the base controls a much larger current flowing from the emitter to the collector. The transistor can work in three regions. Cutoff region. Both junctions are reverse biased. The transistor is off. Active region. The base emitter junction is forward biased, and the base emitter junction is reverse biased. The transistor amplifies signals. Saturation region. Both junctions are forward biased. The transistor is fully on. Explanation of logic gates detailed. Logic gates are fundamental components in digital electronics that perform logical operations based on binary inputs O south and 1 south. They are built using transistors. 1. NOT gate. Symbol, a triangle with a small circle at the output. Operation, also called an inverter, it inverts the input signal. If the input is 1, the output is 0, and vice versa. Implementation, built using a single transistor. When the input is 1, the transistor conducts, pulling the output to 0. When the input is 0, the transistor does not conduct, allowing the output to remain 1. 2. AND gate. Symbol, a curved shape with two inputs and one output. Operation outputs 1 only when all inputs are 1. Otherwise, the output is 0. Implementation built using transistors in parallel. Current flows if either input is 1, making the output 1. 3. OR gate. Symbol, a curved shape with two inputs converging into one output. Operation outputs 1 if at least one input is 1. If both inputs are 0, the output is 0. Implementation, built using transistors in series. Current flows only if both inputs are 1. Otherwise, the circuit is incomplete, and the output is 0.